Hello everyone, welcome back to the course Financial Mathematics for Actuaries. Having understood how to compute the expected return and risk of the portfolio, now let us also understand the optimal portfolio selection. Okay, how to select the optimal portfolio? There is a famous theory, okay, that tells us how to select the optimal portfolio theory. The theory's name is called Markowitz portfolio selection theory, also known as modern portfolio theory. Okay, let us understand this a little bit and then we will stop. So, the goal of the portfolio theory is to construct a portfolio such that it would provide the highest expected return and lowest risk. Such a portfolio is known as the optimal portfolio. Okay. So, the optimal portfolio will have the highest possible expected return with the lowest possible risk, right. So, the conceptual framework and the analytical tool was actually provided by Harry Markowitz in the year 1952. Okay. Harry Markowitz is also received a Nobel Prize in economics. Okay. He has provided a theoretical framework for risk and return analysis and their relationship. Okay. So, the portfolio theory will work with certain assumptions. Let us first understand the assumptions very briefly and then I will tell you in a very simple way what is the modern portfolio theory is all about. So, with very less mathematics, okay, let us now understand what is the portfolio theory is all about. Okay, but once you understand this introductory, you know, lesson, then you can even like deep or you can dig deeper into it. Okay, so investors are rational. Okay, investors are rational in the sense that investors objective is to maximize their goal. Okay, right, and they will like they will act like they believe in the theory. Okay, so investors are risk aver in the sense that at a given time investors want to take risk only if they are compensated with the risk. Most of the investors are risk averse investors. They do not like the risk. Okay. The market is efficient and absorb information quickly. So it also assumes that the market is efficient in the sense that the asset price incorporate all the available information. Okay, remember that efficient market hypothesis or the market is said to be efficient only if the asset price are incorporated or the price or the current market price incorporated all the available information. Okay, so and also it believes that access to information is available to all participants. Okay, if the market is efficient, then everyone should get the same sort of information. Investor base their decision on the basis of risk return criteria. So it assumes that investors understand what they want. Okay, they want highest expected return with a given risk or with a minimum possible risk. Okay, so investor prefer higher return to lower return for a given level of risk. There is no arbitrage opportunity. That means there is no opportunity to make a costless or riskless profit or riskless return. Okay, remember I have already explained you what is arbitrage opportunity. Okay, if two different prices are available at the same time, then you can able to buy the asset with a less price and immediately you can sell it in the other market without like incurring a cost. Okay, and that is why it is called costless return or riskless return. So no transaction costs and also no income tax. Okay, and this theory also assume that everyone has the same opportunity of borrowing and lending. Okay, at the rate that is prevailed in the market, which is known as risk free rate of interest. Okay, diversification reduce the risk. So this theory also believes that investors diversify in order to reduce the risk. Okay. With this, let us also understand what is the portfolio theory. So, what is portfolio set? Okay, or the feasible set of portfolio. Okay, with a limited number of securities, an investor can create a large number of portfolio by combining these securities in a different proportion. Okay, so if you have selected like so this security, then you can actually make different portfolios, right? Okay, any number of portfolio, okay, if you want. So these constitute this set of portfolio or the feasible set of portfolio in which the investor can possibly invest. Okay, this set is known as the portfolio opportunity set. Okay, so what is this portfolio opportunity set? Each portfolio in the opportunity set is characterized by an estimated expected return and estimated risk, right? So, in the opportunity set, some portfolios dominate other portfolio. Okay, you can also understand that some portfolio are efficient than other portfolio. So, the portfolio that dominate other portfolio are said to be efficient, and the portfolio will dominate another portfolio. Okay, if it has either, okay, so we will call like if it has either a lower standard deviation and same level of expected return as the other, or a higher expected return and same level of standard deviation or sigma. Okay, so portfolio that are dominated by another portfolio are said to be inefficient portfolio. Okay, and therefore, okay, the inefficient portfolio should be discarded, right? Remember here, okay, that our objective is to choose the portfolio that will give you a highest expected return, okay, and lowest risk. While searching for this type of portfolio or this type of security, the investors actually compute all the estimated risk and return, and imagine, for simplicity, that we have the information of estimated risk and expected return here given. You can look at here that there are some portfolio that are the same level of risk, okay, but different level of return. Let's say for example here portfolio 2 and 3, we have same level of estimated risk, okay, and expected return. So combining, comparing this 2 and 3, 3 is therefore more efficient, okay, meaning that it has a highest expected return. Similarly, we will have 6 and 7 here, okay, these two, this is also same with the given level of risk, right? 7 is more efficient, which will give a highest expected return, right? like like this, you can also compare that there are some assets that will give the lowest possible risk, but they have the same expected return. For example, asset 10 and asset 18. So we will have here asset 10 and asset 18. We will see the expected return are same, that is 22.6%, but the risk is different, right? So the risk for 18 is higher than the risk for 10. So 10 is therefore more efficient, right? Understood now? Okay, if you plot this, then this will look like the graph we have seen here. Okay, this can be clearly understood by considering a graph also. Okay, but here one thing you need to notice here, that a risk averse investor would like to be in the area of northwest region. So it will be like this, right? Okay, so let us understand this more clearly. So if you could find a set of portfolios that offer the highest return with the same level of risk or the lowest risk with the same level of expected return, then you have identified all the portfolios an investor could consider for holding. Okay. So all other portfolio therefore could be discarded or can be ignored. They are the inefficient portfolios. Okay. So now let us understand this, like very simple way. Okay. Now I think we will be very clear here. Look at this diagram here. We have some portfolio here A, B, C, D, E, F. Okay, plotted in this. Now observe this diagram here. What it says, the shaded area. Okay, the shaded area, this one, okay, represent the set of all possible portfolio that can be constructed from a given set of securities. Okay, within this set, this is called this opportunity set. Okay, so within this set, consider portfolio E and F, this portfolio and this portfolio. Which one you will choose? See, they have the same expected rate of return, but E is having lowest risk than F. So you will choose F. Sorry, you will choose E and F will be discarded. Okay. So portfolio E would be preferred to F, right? Now you can compare A, B, okay, and C here, right? Yeah. Comparing this A and B, which one you will choose, right? They are having the same risk, but B is having the highest expected return. So you want to choose B. So B is the portfolio which will give you the highest possible expected return. So every like investor want to achieve B. Okay. So B is therefore preferable to A. Now also C would be preferable to B, right? Sorry, C would be preferable to A because the same way we have understood here like E and F. So E will, the C will give you a lowest possible risk, okay, with the same level of expected return, right? So portfolio A and F would be ignored here. So this will be ignored and this will be ignored. Okay, and comparing now these two, okay, like E and D. Okay, E would be preferred to D because E will give you highest expected return. Again we will like discard this D, right? No, so this is also not preferred in this. Again moving from D to C, right? Moving from D to C, C provides a higher return and is less risky. Okay, if you compare here between these two, like C and D, C is actually give you a highest return than D. Okay, and also it has the less risky as compared to D. Therefore, as I have already told you, D is also eliminated. So we will eliminate D, we will eliminate A, we will eliminate F. Only we will have C, D, B, right? So here this C is said to be the global minimum variance portfolio. Okay, so point C cannot be eliminated because there is no portfolio that has less risky for the same return or more return for the same risk. Okay, and therefore C is known as the global minimum variance portfolio. Okay, this will be okay. So a investor want to like choose this C. First the investor want to identify this C and then he slowly move on up to B. Okay, he will be like to be in the northwest region of the diagram. That's what actually I was talking about this one, right? So taking this, okay, diagram from C to B, we will get what is known as efficient frontier. So we find that portfolios lying in the northwest boundary of the shaded area are more efficient than all the portfolio in the interior of the shaded area. Okay, therefore, okay, the boundary of the shaded area is called the efficient frontier. I have taken this point, okay, from C to B here, okay, right. So this one is known as the efficient frontier, okay. So the efficient frontier include all the efficient portfolios in the opportunities, okay. The efficient portfolio in the frontier include, here I will write, include all the efficient portfolios in the opportunity set, right. Now how do you select the optimal portfolio here? The particular portfolio an investor would select from the efficient frontier will depend on the investor's degree of aversion to risk. Okay, if the investor is highly risk averse, then he would hold a portfolio in the lowest left segment of the efficient frontier. Therefore, the selection of the portfolio depends on the investor risk aversion or conversely his risk tolerance capacity. Okay, this can be graphically represented through the risk return utility or the indifference curve. So what is this risk return utility curve? The risk return utility curve represents different combination of risk and return, all of which are equally satisfactory to the concerned investors. Okay, the investor is indifferent between the successive point in the curve. So it looks like exactly the indifference curve. Okay, each successive curve moving upward to the left represent higher level of satisfaction or the utility. Okay, the investor's goal is to maximize his utility. The optimal portfolio therefore would be one, okay, at the point of tangency between the efficient frontier and his risk return utility curve. So first you understand what is the risk return utility curve, that is upward sloping. As you can see it here, the orange one, this one, okay, is our efficient frontier, and here I1, I2, I3, I4 are the risk return utility curve. As I have told you, the individual investor is indifferent between any successive point. So whether he is here or he is here, he is indifferent. However, the highest the indifference curve will give him highest satisfaction, okay, or the utility. The investor's goal is to maximize the return or maximize its utility, and the optimal portfolio therefore will be the one which is exactly tangent point, this one, okay, when the efficient frontier is exactly tangent to the risk return utility curve, and therefore sometimes the optimal portfolio is also known as the tangent portfolio. Okay, this is how you can compute the optimal portfolio. Now you can use your mathematics here, okay, to compute this point, and you can proceed, right? Okay, so what is the limitations of this theory? One of the limitations of this theory is lots of data is to be required. So Markovitch used this technique of quadratic programming to identify the efficient portfolio using the expected return and risk of each security and covariance estimate of a pair of securities. Okay, so one problem of this model is that a large number of input data is required, okay, for the calculation, and therefore it is not very popular. Okay, but nowadays we have computer software, so it will be very easy. Okay, so we have to obtain the return, we have to obtain the variance, and we have to obtain the covariance of each pair of securities to complete our model, right? So therefore if there are n securities in the model, then we need n return estimates, n variance estimate, and we have n time n minus 1 divided by 2 covariance estimate, which will result to have 2n plus n time n minus 1 divided by 2 estimates. Okay, for example, here if the investors analyze 200 securities, okay, then he has to compute 200 return estimate, okay, 200 variance estimates, and he has to compute 19,900 covariance estimates, which will add up to 20,300 estimates. So it requires really large input, okay. Otherwise, this theory actually will give us a very good idea of how to choose the optimal portfolio, and therefore it will also give us the relationship between risk and return. Okay, so I believe you have at least understood what is the portfolio theory says, okay, and how, what is the principle of diversification, okay, and what is the, or how to choose the optimal portfolio. I have given it very simple way so that you can able to understand it, okay. But you can, as I have already told you, like you can use your mathematics here and you can actually dig deeper and understand what is the exact optimal point here, okay. So now let us stop here, okay, and in the next week we will be review whatever we have studied from the very beginning, that is loan repayment method to the bond management principle, okay. So thank you very much. We will see you in the next week.